So today we're going to do polynomial and rational inequalities. So here is an example of a polynomial. I do not want to deal with any fractions, so I'm going to multiply both sides of the inequality by 4. The entire thing by 4. These 4's will cancel out, leaving me with x cubed is greater than 4x squared plus 12x. What do you guys think I should do? Not yet. We will do that. I'm going to move all of these items to one side. That's what your instinct should tell you. X cubed minus 4x squared minus 12x is greater than, what should I put here? 0, because there's nothing left over here. We moved it all. Okay, now we're going to go ahead and divide by x. We're going to factor this. I'm going to pull out an x, leaving me with x squared minus 4x minus 12. What can you now do with this polynomial? Factor it even further to linears. What should my factors be? Exactly. X minus 6 and x plus 2 need to be greater than 0. Okay, so we need to figure out what x values would make this polynomial greater than 0. That's what we need to figure out. So we need to test some important values. Which values do you think I should put on my number line? Perfect. What you guys did was you guys equaled each of these things to 0 and solved it, giving you 0 for one of them, positive 6 for another one, and negative 2 for another one. They're not accurate distance. I just put them on there. Okay, so now we're going to test these intervals. Go ahead and test. If you plug in a number that's less than negative 2, will it be greater than 0 or not? Then test a number between negative 2 and 0, 0 and 6, and greater than 6. We're going to come up with our solution set. So if you plugged in a number such as negative 3, let's see what happens. If I plug in a negative 3, a negative 3, a negative 3, I get 3 negatives. That's odd. So this is negative. Now let's plug in a number between negative 2 and 0, such as negative 1. So now I'm going to plug in some negative 1s here. If I plug in a negative 1, let's see what happens. I know this is just negative 1, so it just stays negative. This will be negative 7, that's negative, and this would be a positive 1. So I have 2 negatives, that makes a positive, so this is positive. Now let's test a number between 0 and 6, such as the number 1. So I'm plugging in a positive 1. This is positive, this will be negative, and this will be positive. I have 1 negative, that's odd, that'll be negative. And let's test a number bigger than 6, such as 7. If I plug in a 7, and 7, all of those are positive, this is positive. So guys, our problem said that it wants values that are going to give you something greater than 0. That means I want this interval and this interval, since they're going to be greater than 0. So I'm going to have negative 2 to 0 and 6 to infinity. Now let's figure out our parentheses and stuff. At negative 2, that's going to give you 0. Can we equal 0? No, so these will be parentheses. These will all be parentheses. We cannot equal 0. Okay, if you plugged in a negative 2 here, this would give you 0. If you plug in a positive 6 here, that would give you 0. If you plug in a 0 here, that would give you 0. That's why we have parentheses on all of these numbers. So here's the next problem. First, we need to factor. You always need to try to factor. So how did you guys factor this denominator? What'd you do first? Yep, you take out the negative 2. We're going to divide by negative 2. So we're left with x squared minus 25. And how can I further factor this? Yes, x plus 5 and x minus 5. Okay, so my new problem is x minus 1 over negative 2, x plus 5, x minus 5 is greater than or equal to 0. Now, guys, the other day when we did interval work, what values do you put on your interval? Or what values do you put on this number line? Your zeros, you need to put your zeros on the number line. What else? Vertical asymptotes. Those are the two things that you need to put on your number line to test. Asymptote. Okay. So you must have these. Okay, so guys, how do I find my zeros? What'd you say? Exactly. I'm going to set the numerator equal to 0 and solve. So where is my 0? At 1. So I know I need to test it at 1. How do I find my vertical asymptote? Yes, I have to set the denominator equal to 0, and that is how I'm going to find my vertical asymptote. So I'm going to have a vertical asymptote at negative 5 and 5. Thank you. Okay. So guys, go ahead and test those values and find your solution set. All right, let's test it. You should have plugged in a number that's less than negative 5. I'll pick negative 6. If I put a negative 6 in here, and here for this x, the numerator will be negative. I have a negative 2. I have a negative in this parentheses, and this will be a negative. That is 4 negatives. That's even, so it'll be positive. Now let's test a number between negative 5 and 1. I'll pick 0. So I'm going to pick zeros. So that means if I plug in a 0 here, and here, this would become positive. This is negative. This negative 2 is still negative. And this is a negative. That is 3 odd negatives. That's 3 negatives, which is odd. So this will be negative. Now let's test a number between 1 and 5. I'll just pick 2. So if I plug in a 2, 2, and a 2, I get a positive, negative, positive, negative. That's 2 negatives, which is evens. That's positive. And if I plug in a 6 everywhere, that's bigger than 5. If I plug in a 6, I get positive, 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 and a negative. So that'll be negative. Okay, so those are my intervals. So let's go ahead and see what my answer should be. Now, my equation, my inequality, says I need to be greater than or equal to 0. That means I'm going to pick this one and this one because I need to be positive, greater than or equal to 0. So I'm going to have negative infinity to negative 5. That came from this one. And I'm going to have 1 to 5. That came from this interval. Now, we need to figure out parentheses and brackets. On an infinity, I will always have a parenthesis. What should I have at negative 5 and why? Y'all are all saying bracket, but where did we get negative 5 from? What does negative 5 represent? It's an asymptote. Can you touch an asymptote? Okay, everyone put an A right here for asymptote. Start doing it like that. Put A's on negative 5 and 5. That is an asymptote. You cannot equal it. So I'm going to put a parenthesis on the asymptote. Is 1 an asymptote? No, it's a 0. So we can equal that. But 5 is an asymptote. So that should be a parenthesis. So this is my final answer. So guys, what I want you to start doing is when you put numbers on your interval, for negative 5 and 5, write the letter A so you remember not to put a bracket, but put a parenthesis, because those are asymptotes. You can't equal those. Okay, next one. I'm showing you all the different scenarios you'll come across. So first, let's put them all on the same side. I'm going to move this to the other side, and that's going to give me 8x to the power of 6 minus 1 over x to the power of 3 is greater than 0. Now, do you guys remember how to combine fractions? What do you need to combine fractions? A common denominator. So, what should I multiply this fraction by so that the denominator is the same as this one? Exactly. I'm going to multiply by x cubed. So, remember, when you're multiplying with the same base, you add the exponents. So this will become 8 over x to the 6 minus x to the power of 3, x to the power of 6, greater than 0. Now that my denominators are the same, we can combine this into a single fraction. This will be 8 minus x cubed over x to the power of 6 is greater than 0. From here, we can evaluate it. So I'm going to do my interval work. Remember, you always need to put zeros and vertical asymptotes on your number line. Those are the two things you need to find. So how do I find zeros? Set what equal to 0? Yes, set the top, the numerator equal to 0. And how do you find vertical asymptotes? Yes, the denominator. Sorry, I'm just going to put top and bottom for space. Okay, so let's set the numerator equal to 0 to find my zeros. So the numerator is 8 minus x cubed. Set it equal to 0 and solve. Let me know what you guys get. So you'll get 8 equals x cubed. We know that 2 times 2 times 2 will give you 8. Let's test negative 2 because some people got negative 2. What's negative 2 times negative 2? 4 times another negative 2? Negative 8, not 8. So only 2 is your answer. Okay, so this is one of your zeros. Now, how do you find, or your only 0, how do you find your vertical asymptote? Yep, set the bottom equal to 0. So what's the answer to that? 0. So we're going to test 0 and 2. 0 is your asymptote. Please write an A on it. It should never have a bracket because it's an asymptote. Go ahead and test these. All right, did you guys get positive, positive, negative? Yeah. Okay, perfect. So we want to be greater than 0. So that would be this interval and this interval. Okay, so that means I'm going to have negative infinity to 0. And that's an asymptote, so it should be a closed or a parenthesis right here. And then from 0 to 2, can you equal the 2? Yeah. No. Why are y'all saying yes or no? Yes, you should be saying no because there's no equal to sign on these. Right? These are only greater than, so we cannot equal 0. If you plugged in a 2 right here, you would get 8 minus 8, which is 0. We don't want to equal 0. So I'm going to have a parenthesis on the 2. And this is your answer.